pairs, it seems almost kind of silly. The main piece of that is your domain and range. And then yesterday with functions, understanding that on your function, your x value cannot repeat. This really mixes into as we start to talk about graphing linear equations, aka lines. We're going to start to graph lines. And I know, and here's the thing that people hate the most, I know you've done this before. I understand that. But there are certain ways that I want to go over it every single day. Okay, so just understand, I know there's other ways to do this, but we need to focus on each day for a certain reason. So the first thing we're going to talk about today is just the standard form of the equation. A linear equation. A linear equation is an equation that forms a line when it's graphed. I can't remember if I already told you this or not, but this entire chapter is online, including the test. Okay, I thought I told you that, but I couldn't remember. All right, so the first thing we have to talk about is standard form of the equation of the line. Standard form is written in as like the main way of showing it, ax plus by equals c. And you're looking at that like, what? Really, we think of it as a, b, and c are normally numbers. Okay, a, b, and c are normally numbers. And there's 3 rules of standard form. First one, A must be positive. The A value, or your x term, must be positive. A and B on one side, C is on the other. And A and B, I really mean your x and your y need to be on one side. And C is just going to be a number by itself, no letter with it, needs to be on the other side. And the rule that we actually like the most about standard form is absolutely positively no fractions. No, that doesn't mean we're not going to deal with them today. It just means that if the answer has to be written in standard form, it can't have a fraction in it. So if I gave you an example of something written in standard form, would be like 3x minus 7y equals 12. Okay, 3x minus 7y equals 12. The number in front of x is positive. X and y are on one side. The number by itself is on the other, and there's no fractions. We need to make a note, because I forgot this. To determine if something is linear, x and y cannot multiply together. X and y cannot multiply together. X and y must be, oh no, let's not do that. X and y cannot be in the new denominator. X and y cannot be in the denominator. No exponents greater than 1.
Is there a 1 exponent?
Well, that's just like when you write x or y. Technically, there's a 1 there. We just don't write it. So like 3x is a 1 exponent, but 3x squared is a 2 exponent. Does that make sense?
Yeah.
It's like an understood there. Okay, why did we write this down? Because our directions in this section says, determine whether the equation is linear. If yes, then we have to write it in standard form. So the first thing we're going to do is first we have to check if it's linear. If it's not linear, we're not wasting our time on standard form. Okay? So if we look at our first equation, y equals 4 minus 3x. Are x and y multiplied together? No. Okay, we're good there. Are x and y in the denominator? Nope, we're good there. Do we have any exponents greater than 1? So is this linear? Yes, it's linear. Because it's linear, we have to write it in standard form. Now, the best part about it is so far, there are no fractions, so we don't have to worry about that rule. But the other two rules say x has to be positive, and x and y have to be on one side with everything else on the other. So look at your x term. Is x currently positive? What is x right now? -3. How would I make him positive? Add him to the other side, yes? If I add 3x to the other side of the equal sign, I have a positive 3x, a positive 1y equals 4. Is x positive? Are x and y on one side and everything else on the other? Do we have fractions? This, standard form. Go down. 6x minus xy equals 4. Is that linear? Why not? Bingo. So x and y are multiplied together, so not linear. And maybe you want to make a note to yourself. X and y are multiplied together. Sometimes I always like, oh yeah, in class it makes sense. And then at home you go like, why did I write not linear here? I don't remember why. It's not linear because x and y are multiplied together. Because it's not linear, we don't have to worry about standard form. 1/3 y equals -1. Is that linear? No? Why not? But does it say you have to have x? It just says x and y can't be multiplied together. I don't think they're multiplied together. It says y can't be in the denominator. Technically, y is over 1 right now, right? So we're good there. And we can't have an exponent greater than 1. This is linear. You don't have to have an x and a y. If I want to write this in standard form, what rule are we breaking right now? Fractions. So how do I get rid of fractions? Multiply by the denominator. You don't want to flip it because if it's 2/3 and you multiply by 3/2, you end up still with a fraction, right? The part of the fraction we hate is the denominator. So we're just going to multiply by the denominator of 3. But whatever you multiply by 3 on one side, you have to multiply everything by 3. So when I multiply by 3, what do I end up with? 1y equals -3 because your 3's cancel here, yes? Now, is x positive? What is x technically? 0, right? Now, 0 doesn't really fall under negative or positive. Are x and y on one side and everything else on the other? Technically, yes, because there's not an x. Do we have fractions? We're good here, standard form. Y equals x squared minus 4. Linear, yes or no? Why not? Very good. Not linear. You have an exponent greater than 1. Any exponent other than 1, no good. No good. So what you're going to see today is they're going to give you a bunch of different equations, and you just have to determine, yes, they're linear, no, they're not. And what you're looking at is your variables can't be in the denominator. They can't be multiplied together. And if you have any exponent greater than 1, not linear. All right. Linear equations are graphed on a coordinate plane. Coordinate plane always seems intimidating to us. Coordinate plane is the x comma y. You guys know what a coordinate plane is, right? Don't overthink, okay? We can graph a line on here by using our x-intercept and our y-intercept. By the raise your hand, who can tell me what an x-intercept? Describe to me what an x-intercept is. Sophia. Okay. Anybody want to make changes to her description when a line goes over the x-axis, passes through the x-axis? Thatcher?
Oh yeah, I was gonna say that, but when a line intersects the x-axis.
And the word intercept or intersection, like you guys are going to be talking about driving, right? Where two things meet or cross. And so this is where a line, whoops, spell the word correctly, where a line crosses the x-axis. The x-intercept is where the line crosses the x-axis. And it's a point, right? An x comma y. Here's my question. There is something that every x-intercept has in common. Every single x-intercept you give me has something in common. Anybody know what it is? Mason? Nope. Alyssa? Nicely done. That is 100% correct. Every x-intercept, your y is equal to 0. Now let's think about this. How come the y is equal to 0? Morgan?
Because it's on the x-axis.
It's someplace on this x-axis. What does your y value tell you to do with a point? Go up or down. Did we go up or down? No. Nicely done. So you know that every x-intercept is always whatever your x is, comma, 0. Every single time. Every single time. Okay, so for the definition of a y-intercept, we can basically change the letter. Agreed? So the y-intercept is where a line crosses the y-axis. Now, Alyssa told us the x-intercept, the y is 0. On the y-intercept, is it? What does your x-coordinate tell you to do? Left or right? If you're on the y-axis, did you go left or right? Bingo. So x equals 0. So this point is always 0, comma, whatever your y value is. And this, truthfully, is the biggest piece right here. The opposite coordinate is always 0. X-intercept, y is 0. Y-intercept, x is 0. The opposite is 0. The x and y intercepts will help us graph linear equations. These two intercepts can be written as ordered pairs, and you only technically need 2 points to draw a line. Part of the reason I love to do this on ALEKS is because we don't need a bunch of rulers and we don't need a bunch of graph paper because ALEKS helps us graph, yes? It's really slick for that purpose. Okay, so let's flip it over. Here's what I'm going to warn you. Algebra kids are always like, oh, we know how to do this. We don't have to show any work. And then they get it wrong. Okay? Find the x and y intercept of the line. This is what I would ask for you to do on your work page today. If I'm going to find the x-intercept, Alyssa informed us our y equals 0. To find our x-intercept, our y equals 0. So take your equation and plug in 0 for y. You would have 4x minus 6 times 0 equals 36. Now, what is negative 6 times 0? 0. So really I have 4x equals 36. Divide by 4, x equals 9. So my x-intercept occurred at 9. You could also write that as an ordered pair of 9, comma 0. Then you have to repeat that process for your x or for your y-intercept. Your y-intercept, x is 0. So we take our equation, we replace x with 0. 4 times 0 minus 6y equals 36. 4, bless you twice. 4 times 0 is, what do I got to be careful of with this one? Negative. Negative 6y equals 36. Then I should divide by negative 6. Y equals negative 6. So your y-intercept is at negative 6 or 0, comma, negative 6.
So then is the final answer 9, comma, negative 6.
Those are two separate points. If you tell me 9, -6 on a coordinate plane would be 9, -6 down here.
Yeah. That's what I'm saying.
No, because I'm asking two separate points. One of them is going to be on the x-axis. One of them is going to be on the y-axis. Two separate points. That's why I wrote these down right here. Okay. Not one point, two separate points. So this is actually a screenshot right off of Alex. The equation of the line is given below. Find the x-intercept and the y-intercept, and then we're going to use them to graph the line. I want you guys right now, on your own, showing me work, find me the x-intercept, find me the y-intercept. Don't graph them yet. Just find me the x-intercept, find me the y-intercept. So I got the x-intercept to be 9 and the y-intercept to be -3, yes? Okay, and I know this is silly and you're going to look at me like I'm a crazy fool. Everybody look at this graph. Every time we do this, people graph this incorrectly. There's not 9 on the graph, Miss Hoff. The graph doesn't go to 9. That doesn't make it have 9.
It goes by 2 with halves.
In other words, it goes by ones. No, it goes, yeah, it goes by 2s, but it has halves. That's 1.
It doesn't say the halves in between.
It goes by 1s. It just labels every 2. That doesn't mean your scale is not 1.
I know that. It's like, I'm saying that there's halves in between, like, where the 1 and the 2. Why don't they honor it?
Okay, just say in between
Okay.
the numbers.
So 9 is out here. So to graph this, what you would do is put a point on 9 on the x-axis, and you would put a point on -3 on the y-axis, and normally we'd have a ruler and we would connect these two dots, but Alex will do it for you. Okay? Every time today, everybody look at me, every graph today, one of them is on the x-axis, one of them is on the y-axis. Every problem today, because how are we graphing? Using the x and y intercepts. Okay? We're going to skip that problem. Go to the back. Graph the line x equals 1. Every problem today, we are going to graph using the x and y intercepts. What do you know about every x-intercept? Y equals 0. Oops. So take your equation. Plug in 0 for y. What do you get? X equals 1. Good job. Nobody fell for it. Usually somebody says, Miss Hoff, there's not a y. Well, then do we have anything to replace with 0? No. So guess what your x-intercept is? Your x-intercept is at, oh, sorry, 1, not -1. 1. Okay? Every y-intercept, your x is 0. So take your equation, plug in 0 for x. What do you have? Equals. Where did a y come from? 0 equals 1. Does 0 equal 1? No. This is not true. That means there is no y-intercept. There is no y-intercept because there's, first off, there's no y in the equation. How do I graph a line without a y-intercept? Yes, you do, Emily. Careful. Be vertical, right? It's going to cross the x-axis at 1. How can I draw a line through that point that never crosses the y-axis? It would be up and down vertical. Usually people yell, it'll be straight. All lines are straight. Okay? So without even having to graph it, what would somebody give me an example of an equation that would be a horizontal line? Y equals 2, y equals 5. What is easy to note, if there's only one letter in your equation, that is the only axis it will go through. If there's only an x, it only goes through the x-axis. If there's only a y, it will only go through the y-axis. You don't have to have both letters in order to create a linear equation. All right, we're going to skip the next one. We're going to go down to the bottom. Now, I know it's painful for you to tell me that we're going to graph this using our x and y intercepts because some of you are like, we know an easier way. I understand that. But today we're graphing using x and y intercepts. So I ask you again, what do you know about every x-intercept? Y equals 0. So we take our equation and we take y out and replace it with 0. 0 equals negative 4/3 x plus 1. Now, this is true. Just pretend that this is an equation from chapter 2. How do I solve for x? Minus 1 to both sides. 0 minus 1 is negative 1 equals negative 4/3 x. Then I should multiply by the reciprocal, which is negative 3/4. Say it out loud, Mason. Why did I say that? I did say that.
You're not trying to get a fraction answer.
I'm not trying to get rid of fractions. I'm trying to solve for x. Before, we were just trying to dissolve our fractions. Okay, great observation. Good question. Okay, these cancel. X actually equals positive 3/4, yes? Correct? Okay. Somebody tell me how to write that as an ordered pair. How do I write my x-intercept as an ordered pair? Caden?
0.75.
Oh! I thought you said a decimal for a minute there.
Oh, I know. I get the percentage. How would you grab a percentage?
He didn't say a decimal, did he?
You did.
I did.
I don't think he did.
0 and 500. Still a decimal. 3 and 4. 3, 4.
3/4, comma, 0. My x was 3/4, my y is 0. Ooh, no decimals. No decimals. Okay. What do you know about every y-intercept?
X equals 0.
X equals 0. Take your equation, replace x with 0. Y equals negative 4/3 times 0 plus 1. Ooh, what's nice about this? Cancels out, right? Anything times 0 is 0. What's my y-intercept? 1. Somebody write that as an ordered pair. Nice, nice. Now here's what I'm going to tell you. Here's what I'm going to tell you This one is easy to graph. You just plot the point, right? 0, 1. 0, 1 would be like right here. This one on Alex, over in your tools, there's a button that looks like this. And when you click on it, it pops up and says, where do you want the point to be placed? And you type this in and then click plot, and it will put it on the graph in the perfect location. Okay? And no, it doesn't want a decimal. It tells you that. Do not write as a decimal. Please write as a fraction. That's what I want to see. All right? Then you click the graph button and it'll go. I have one more for you. Flip over on the back side of this. Because you're like, how are people screwing this up? Miss Hoff said that algebra kids make a mistake on this. I don't know how they would ever do that. 8x minus 5y equals 14. Write your answer as an exact value. $14. 8x minus 5y, and the directions say find the x and y intercept. Write your answer as an exact value, aka no decimals. All right, what do you know about every x-intercept? Y equals 0. So I take my equation and I replace y with 0. 8x minus 5 times 0 equals 14. What happens? Yep, negative 5 times 0 cancels. 8x equals 14. Then I divide by 8, and all of you grab your calculators, and you type 14 divided by 8, and you get, but I don't want a decimal. Very good. 14 over 8, it will count it wrong because it's not simplified, is really 7/4. So you would tell me my x-intercept is at 7/4. No, mixed numbers are useless to us. You will never write an answer as a mixed number. Y-intercept occurs when x equals 0. So now this time I really have 8 times 0 minus 5y equals 14. 8 times 0 cancels out. I'm left with negative 5y equals 14. Divide by negative 5. And because we're addicted to our calculators, we immediately pick them up and take 14 divided by negative 5, and we get a decimal. So what do? Just drag that straight down. The only thing I would do is put the negative sign up in the top, because otherwise I'll lose it. And check, can I reduce? Done. Will you have work to show me today? Yes. Now, some of them say, determine if the equations are linear, and it's a yes, no. You don't have to write those down, okay? But these are what you're going to have to write down. You can't simplify. Nothing goes into 14 and 5. This is an improper fraction. I don't want a mixed number. Bigger number on top. I don't want it like negative 2 and 4/5. The same way. You click that button and it says, where do you want this to be graphed? And it will plot it for you. And then you just have to connect the dots. Okay? Online.